Hi there, I'm Hao. This is just another video of me solving random code problems. So let's begin. Um, so given a root of a binary tree, return the level order traversal of its node values. So this is a breadth search problem, right? We're gonna look at the node here, top to bottom, left to right, right? So 3, 9, 20, 15, 7, right? Like this. And we want to store them in the corresponding level. So level 102, right? 1012. Okay, pretty straightforward. So because it is a breadth first search, I can use a queue for this. We're gonna have a result array. So our base, so if we don't have a root array, we can just go ahead and return an empty array. Okay. So we also need a queue. We can initialize with the root node and then the val. Oh, sorry, the level which is 0. The while queue dot line. Right. Um, we can look at the node and the level here. Equal to queue dot shift. And we're gonna push it into our result for the corresponding level. So if result level equal to an empty array, if we don't have the subarray, then we create an array, and after that we cannot push it, push in the value. We need to look at the, and then we need to uh push in the children, right? So we need to push the left children first, and then the right, because we are looking from left to right here. And for the queue, we know that it is first in, first out, so we push the left first. So if we have the left child, then we push the left child, note that left with the level here, the next level, level plus one. It is right. Right. All right, run. Let's see. Okay. So even though it is passing, the problem we have here is we are using the queue. So the time complexity now is O of n, right? But because we are using an array as a queue, so every time we remove the element on the left, we need to shift over all the index, right? So if I remove the one, right, I need to shift the index here, 3, 1, 0, 1, 2, right? So that is also O of n. So in JavaScript, there's no custom um, queue class. So I think we can create our own custom uh, queue class if you prefer. So why don't we just give it a try? We're gonna have a class of my queue here, right? We're gonna do nq, right? And dq, nq, we take in the value, and then we need dq in the value. We need a constructor, right? So we need to keep track of the length, right? 0. We're gonna use a hash map to implement them. So we can do um just a q equal to hash map. We're gonna keep track of the index, right? The left and the right index. So let's call this, what is it? Left index is 0. Right, this the right index is is 0. Let's call this yeah, left and right. Or front and back. Let's call it front and back. Front and back. Yeah, front and back. Okay. I don't think we need a function keyword here. We need ES6, so okay. So how do we enqueue? We can do this dot let's call it items. Okay, this dot items. Items are just dot back index. right? So we use the back index because we always push from the right side, right? This back index is equal to the item, for the item, yeah, item. And we're gonna increase the length, right? And also the back index. Okay, so we have the items here on the back index. We enqueue, we push it, we put it into the hash map, which is O of one, and we increase the back index and the length. So when we dequeue, we're gonna do if is that length is less than one, then we're just gonna return it. So how do we dequeue? We dequeue from the left side, right? So we're gonna get the item equal to this dot item of the front index, this dot front index, right? And do delete this dot item, uh, this dot front index, we'll do return the item. Well, actually, we don't even need to return the item here. It's for our use case, we don't even need to return it, right? So we don't have to do that. We can just increase our front index there, and then discrete the line. So we won't have to we never have to worry about um overlapping key because the right and the left index is always moving to the right, right? Yeah, normally we can have a print queue or the pick method, but I think it's not important here for our use case. So instead of the queue here, we can create a custom queue. So my queue here, and we can do queue dot queue, and we're gonna put in the array, right? Instead of doing shift, we can do requeue. Scan for here and queue, right? That's pretty much it. And then because we use a hash map, right? So the delete is will be over one for amortized time complexity. Okay, let's give it a try here for our custom um oh new. So now our delete will be O of one, right? So the overall time complexity will be O of n. Uh, so I think we have some problem with the name here. So let's call this like q. Um, my q, my q, uh, my q. Okay. Oh, unify is not iterable. Unify. Oh, yes. Okay. When we DQ, never mind. We do need to return the item, right? Because we want to destructure it. So yeah, we need to set the item before we delete it. My bad. Oops, another typo. Just the front index. All right. Accepted. Submit. Okay. Thank you for watching.